Hi, I'm Karen, and as you may remember me from Chapter 6, in this chapter 10, we will be learning all about triangles and their concepts. So let's get started. The lesson today is the sum of a triangle's interior angles. Chapter 10, learn the concept of how the angles of a triangle add up to 180 degrees. Learning goals for today. Understand triangles and related concepts, and being able to correctly identify and represent triangles. Is able to classify triangles according to the size of the angle. Master that the sum of the interior angles of a triangle is equal to 180 degrees, and will solve simple problems accordingly. So now I want you to take a close look at the pictures I'm going to be showing them. What do you see in them? What types of 2D geometric shapes that we've been learning about recently? The concept of triangles. Question 1. Observe the formation process of the triangle below, and talk about what a triangle is. Definition: a figure composed of three line segments that are not on the same straight line, which are connected in sequence, is called a triangle. There are three line segments and three angles to a triangle. A side of a triangle is segments AB, BC, CA are the sides of the triangle. Points ABC are the vertices of the triangle. Mind you, the word vertices is just a plural form of the word vertex. And an angle is angle A, B, and C are the interior angles of the triangle. Here's a representation of a triangle. Triangle ABC can be expressed as, here we draw a mini triangle, then we write the points A, B, C. Side representation. Sides of a triangle ABC, AB, AC, and BC can be expressed with lowercase letters as CAB. So as you can see here, this is covered a little bit, but this is point A, point B, point C. And since this is point A, this side right here, side C, can also be known as AB, and side A can be known as BC, side B can be known as AC. But the reason it can also be expressed by lowercase letters, and there's a catch to that. Do you see how, in a triangle, each angle has an opposite side? Do you see that? Same for this one up here. It has an opposite side facing it. Now, since this is point C, the opposite side facing it has to be side C. The opposite side facing point B is side B, and the opposite side facing point A is side A. And remember, you have to make sure that when you're either doing a line segment, a line segment, and in a triangle, you have to make sure that it has to be lowercase, and the only way this side can be side C is if this point is called side C, and there is no other way this can be called side C. Same for the other sides. Side C, the corresponding angle to it, or the point to it, has to be point C. Point B, side A, point A. And if it's not a point, it has to be lowercase. Remember, if it is a capitalized lone letter, then it usually represents a point. So remember that. Distinguish. Does the following count as triangles? Well, for the first one, no, because it has to exactly, the line segments has to exactly come together to one point. It can't be any less or any more than that. It has to come together perfectly. Same with the second one, that's also no. And for the third one, these are too short. You have to be able to line them up exactly. Important reminder. A triangle should meet the following requirements. 1. Positional relationship. Sides cannot be on the one same line. 2. Connections of side, end to end. Representation. Triangles are represented by a little triangle sign, expressed as triangle ABC, read as triangle ABC. In addition, triangle ABC can also be expressed as triangle BCA, triangle CAB, triangle ACB, etc. Basic elements. A triangle's sides, side A, B, B, C, C, A. A triangle's points, point A, B, C. A triangle's interior angles, angle A, angle B, angle C. Mind you, the triangle it's talking about right here is just a triangle A, B, C. That's just an example over here. Not every single triangle is called triangle A, B, C. There's triangle A prime, B prime, C prime, there's triangle Z, X, Y, different type of triangle. But this is just an example, so I don't want you to get confused. Special regulation. For the three sides of triangle ABC, the side facing vertex A is generally denoted as A. The side facing vertex B is generally denoted as B. The side facing vertex C is generally denoted as C. So, I just first want you to take a moment and just quickly jot down what we just went over. Basic elements, special regulations, a triangle should meet the following requirements, and representations. All done? Great. Now we're going to use that information you just collected and we're going to do some problems. Find. How many triangles are in the figure? How do you mathematically express these triangles? So, well, first, how much triangles are in the figure? We just simply count. So let's start with the smallest triangles. So there's this triangle right here. That's 1, 2, 3, and the bigger ones, 4, 5, and there's no more. So 5 triangles, and we just express them. So triangle ABE, triangle ABC, triangle BEC, triangle BCD, and triangle ECD. 2. What triangles have side B? So which of these triangles that are up here contain side AB? Well, just look which one of these in the names have AB. Triangle ABA, triangle ABE, triangle ABC. 3. What triangles have point E? Now we just see which of these have the letter E in them. Triangle ABE, triangle BC, and triangle CDE. This is triangle CDE, this is triangle ECD. 4. How many triangles include angle D? Then of course there's just triangle BCD, triangle DEC. 5. Write the three vertices and angles of triangle BCD. So the three vertices are points BCD, then the three angles of triangle BCD are angle BCD, angle BDC, angle CBD. The sum of the interior angles of a triangle. Explore. Draw a random triangle on a piece of paper, then cut out its interior angles. Sorry, I keep mispronouncing that word. And this has a false word right here, sorry. I can't get my pen here. So instead of this it's actually this it's interior angles and place them together. So on a sheet of paper, you're going to draw a random triangle, any triangle. And then you're going to cut out its interior angles. You don't have to make sure you contain the whole triangle, just cut out its angles so that you have each full angle. Then what you're going to do is place them next to each other so that now you can see the angles placed together add up exactly to one straight line, a straight angle, 180 degrees. Same any other way. You place them any other way, it's always 180 degrees. The three interior angles of the triangle are put together to form a straight angle. The results of the above observations are not necessarily reliable, and they need to be explained by mathematical knowledge. From the above process, can you find the proof of how this works? Are there other methods? So here's the conclusion. We know that there is triangle ABC, so we want to prove that angle A plus angle B plus angle C is 180 degrees. Remember, the sum of the three interior angles of a triangle is always equal to 180 degrees. So how do you prove this? How do you prove this? How do you prove this equation as well? Well, here's a triangle. Same thing as this triangle here. Then you cut out its angles and you place them together. That was straight. And that's the same thing with this triangle. Proof 1. Across point A, draw line L so that it is parallel with line segment BC, or side BC. So, angle B equals angle 1 right here. Because the two straight lines are parallel, and the internal staggered angles, remember you learned this, the internal staggered angles has to be equal. When, see how these are internal staggered angles? These two line segments, line L and line segment BC, are parallel, so that's what makes them equal. So, angle C equals angle 2, the same reason, and angle 2 plus angle 1 plus BAC equals 180 degrees. So therefore, angle B plus angle C plus angle BAC is equal to 180 degrees. Proof 2. Extend BC to D through point C to make CE parallel with BA. So extend BC to D through point C to make CE parallel with BA. Angle A is equal to angle 1 here. The two straight lines are parallel because AB, let me write this. AB is parallel with CE, so it means that these two angles right here are equal because they are internal staggered angles. And angle B is equal to angle 2. The two straight lines are parallel and the co-position angles are equal. Angle B and angle C are co-position angles. And so angle 1 plus angle 2 plus angle ACB, this angle right here, is equal to 180 degrees. So that means, therefore, since angle 1 and angle 2 is equal to angle A and angle B, angle A plus angle B plus angle ACB is equal to 180 degrees. Think, do you have any other methods? Proof 3. Through D, make DE parallel to AC. DE parallel to AC. Make DF parallel to AB. Angle C is equal to angle EDB. So these two angles are equal. And angle B is equal to angle FDC. The two straight lines are parallel and the co-position angles are equal. These are co-position angles. Angle B and angle FDC are co-position angles. Angle A plus angle AED, angle A plus angle AED is equal to 180 degrees. Remember why? Because since these are the same-sided internal angles, and since these are parallel to each other, then that means since these are one-sided internal angles, they have to equal 180 degrees when summed up. Then angle AED plus angle EDF is equal to 180 degrees as well. Same concept. So angle A is equal to angle EDF, which means angle EDB plus angle EDF plus angle FDC is equal to 180 degrees. So angle A plus angle B plus angle C is equal to 180 degrees. Triangles classified with angles. Everyone, draw a right angle. Then draw another triangle that's not a right angle. After you have your 3 triangles, or actually 2 triangles, compare them. A triangle with 3 acute angles is called an acute triangle. This is an example of acute triangles. It has 3 acute triangles. This, when you see this little sign right here, means it is a right angle. This is a right triangle. A triangle with one right angle. I should make this clear. 3 acute triangles. One right triangle is called right angle. Is called a right triangle. So this is what we call the leg of a right triangle. Then the diagonal here is called the hypotenuse because this is the longest side. Remember, a diagonal line is always from the same distance to another distance is always, so you should know that the concept that a diagonal line is longer than a straight line, and this isn't full, but I think you get that idea. And this is point ABC. This is an example of a right angle. Right triangle ABC can be written as RT triangle ABC. This stands for right. Right triangle ABC, right. And this is another triangle here. Obtuse triangles. A triangle with one obtuse triangle is called an obtuse triangle. Classification of triangles by angle. Triangles. and it is split up into right triangles, acute triangles, and obtuse triangles. According to the sum of a triangle's interior angles are 180 degrees, we get the two acute angles of a right angle are complementary. Class summary. Today we learned all about triangles. And the first section we learned about was the concept of a triangle, a closed figure composed of three line segments that are not on the same straight line connecting end to end. Then the other two main points we learned about was the interior angles of any triangle add up to 180 degrees, and the two acute angles of a right triangle are complementary. When solving problems, these are key points you want to memorize, key concepts that will be played with when solving problems. So you might want to jot this down. And then we learned about triangles by angle, which was split up into three groups: right triangles, acute triangles, and obtuse triangles. The three main skills we learned today was, first skill, understand triangles and related concepts and being able to correctly identify and represent triangles. It's able to classify triangles according to the size of the angle, and master that the sum of the interior angles of a triangle is equal to 180 degrees, and will solve simple problems accordingly.